All right, I think we're ready to go. Last time we worked on the, what did we work on? The larger nozzle. We'd already installed it, but we had put a 0.8 millimeter nozzle in our printer, and we kind of went through some of the calibration, getting it set up, all that sort of stuff. We did some prints. I went later on, and did a couple of calibration prints. So lots of these little things here with trying to mainly get the Z-seam a lot better. So we started, let's see, I numbered them. Started, the Z-seam was, you're not going to be able to see it there. Let's look at the other one. There's some stuff we'll look at in a minute. And maybe printing them in white material is not the ideal camera. So you can't really see, it's just a big white square. But there is a pretty noticeable Z-seam right down here. It turns out that I eventually printed a bunch of these, and I did get it better. The main problem that it was having was when I set up the Cura, it was thinking it was a Bowden tube printer, and it had a lot of retraction, like 5 millimeters, where this is a direct drive printer, and it needs maybe half a millimeter or 1 millimeter of retraction. So I fixed that, and then it worked a lot better. It still is noticeable, the Z-seam, but it's at least closed in, and it's not as bad. It's really, really hard to get it completely vanished, but we did get it much better. All right, so that was last time, and a little follow-up on things that I did in between then and now. Now, well, let's look at this stuff right now. So this is a print that I found on, I guess, Maker World. That's Bamboo Labs site, like Thingiverse. And one difference about Maker World is that it does have files that you can just download and use on any printer, but it also is set up, obviously, for Bamboo printers to take advantage of, and it will download the entire print profile, you know, the settings. You can even say that, hey, that setting doesn't work that great. Here's a little bit better, and you can tweak it and re-upload that setting. You know, all the setting parameters for printing, you can re-upload those, and as just a user, not necessarily the creator of the file. Anyway, I downloaded these and printed out a set. This is a modular system that is for Atari cartridges, like Atari 2600 and 7800. They would both fit. What I wanted to show you about it, though, is that a lot of people don't use 3D printing for functional things. You know, it's more decorative or just to print something, but you can get actual functional prints from FDM printing. So all the black material here is just PLA, but the gold color, this is a PETG, and the reason it switched over to that is the spring. So it's got a built-in spring in there, and the idea is that in the slots here, they have made allowance for you to put these little spring-loaded catches, you know, in here, so that you can slide these things together. Let me see if I can slide them the right way. I have them in the wrong hands. So you could, it does have little screw holes where you could screw them together, but if I can get it straight, they just snap together, and then they hold in place. You could go in right here on the side and pull that little catch down if you wanted to release them, but I just thought that was a pretty cool way of designing something, all 3D printed. There is, I did put one screw in, see if I can get that one to, that one's not working ideally. It does have some tolerance issues. The very bottom one I put a screw in because it's got a different base, and it will have little rubber feet, so TPU feet down here if I decide to put those in there. But pretty functional. It has, you know, you don't want this on the top, so it has a little top piece that cleans it up, and then you've got a little holder for you know, some games. They all just go in there pretty perfectly. I decided to put the 7800 games in here. I have one more. So, you know, this one, there's no slot for it, but all you do is you print another row, print the little clips, take the top off, and keep adding, well, as tall as you want it to go anyway. But that's a pretty functional little print. I'll put it back there in the background somewhere at some point. I was just going to show you that one as a, you can print usable functional things with FDM printing. Good material choices. So the file for that one does specifically say, let's see if I have it pulled up still. I may have closed it. No, I still have it. It was this one right here. The file does specifically say that it is better to print the, well, it says it's actually required. So PETG for the quick clock, the little, and there's their orange. I just didn't have orange PETG on hand. So it is required for that because PETG is not quite as brittle as PLA. It's going to be more flexible, and you're using it as a little spring in this case. PLA would either, it probably wouldn't crack, maybe it would, because it doesn't look like the spring has to compress a whole lot. You know, there it is. But it might creep over time, and since it's in a, I don't know, it's helping to lock the little levels in place. You wouldn't want it to come loose, although I think even without the springs it would be fine. One thing about this, so this relies on little dovetail joints types of connections. You know, this rail here slides into a slot, a matching one. So if your printer is not set up with a pretty good level of accuracy, so you don't have your tolerances dialed in, you're over extruding, something like that, then these dovetails will probably not work very well. I would not print an entire set of these and then test to see if they fit together. So just be aware of that. This one printed one shot. Again, it has a little print profile that the usually the designer is the one has uploaded the first print profile. Not all the time. In fact, this one looks like the designer is Gerari, and the profile is coming from Brandon. So I assume different person. But usually there'll be multiple of these print profiles out here. All of these are specific for different bamboo printers, but you can take and download just the files and print them on your own. So anyway, that was just showing some functionality from 3D printing. What we're doing today is we're going back to our printer, and it's working fine. We've got the 0.8 millimeter nozzle in here. We've got the little bed sensor. For right now, I've got a smooth PEI sheet on there. And we were talking, you know, when I was installing, or throughout the whole quarter, we've been talking about, I'm running Klipper on this machine. I didn't ever install Klipper as part of the course, though, and it wouldn't really make a whole lot of sense. I could, but it wouldn't really make a whole lot of sense to just reinstall Klipper on a machine that already has Klipper. But it did make me think of, there is one thing I don't like about this printer. So this is the absolute cheapest Ender 3 you could get. It's not a Pro or anything. It's the cheapest Ender 3 you can get. Usually, if you wait until one of the sales, I didn't see them on the Prime Day sales this time, but usually the Black Friday sales, somebody will have these low-end Ender 3s for $99. So that's what this is. But as part of that is it's got the lowest end hardware that Creality offers at the time, which means the board in here is a older board, and the control board. I don't know if I can get that over there. So this little control board in here where everything's plugged in and it's sending all the signals. Now right now all the processing is happening over here on this Raspberry Pi because that's where Klipper comes in. But the board still sends out the commands for moving the steppers, taking the data from the thermistors, all that stuff. And the problem with this board, it works fine. It does move around and it prints and all that. Problem is that the stepper drivers, the things that actually control the stepper motors, which control the motion of our printer, including the extruder, they are not silent stepper drivers. They're pretty noisy stepper drivers. So the way the stepper motors get driven is through a series of pulses and electrical signals, and there are different drivers, little computer chips, that can do that sending of those signals. The ones in this board are not silent stepper drivers, but you can replace them or replace the whole board, and you can't replace these actual drivers. They're surface mounted. I guess you could. They're surface mounted on the board, so that would be difficult to replace. It's not like they're little plug-in sockets that you could just pull one out and put another one in. So what I did is I went to Amazon and got this guy on July 18th. Apparently it came in yesterday, and this board will replace, like, it's a drop-in replacement for the board that's already in our printer. It was $44. There's a whole bunch of other ones in here. You know, they've got all kinds of stuff, kits and stuff. We got the, I guess, cheapest one. There's another one, actually, that's the same. Well, so I don't know what the difference is. They've got the USB cables in different orientations, but that's the same board. All these others are maybe different combinations of add-on boards or screens and all that kind of stuff, and they cost more money. We got the cheapest one because our real goal is put this board in and really just use it for the stepper drivers and the end stops and, you know, stuff like that, the thermistors, power distribution, that kind of thing. But then we'll install klipper on top of that and still use our klipper as our processor to process the G-code. But this board has the silent stepper motors on it, and it will be a very much different experience sitting here next to this printer and printing. Maybe while it's still on, let's get a kind of idea of the sound of this printer. Now, I already have gone in and well, back here I added a little fan duct because the power supply fan was actually pretty noisy. This board won't change anything with the power supply fan. I did put a little duct that at least rerouted the air, and it did make it quieter, at least from this direction. So once this boot, I may have to get klipper going too, though, for it to have the screen on. I'll just home the axes or something so you can hear where we're at right now as a baseline, and then hopefully we'll get the whole new board installed and at least get it to run. We'll probably just put Marlin on it to begin with, and it maybe have Marlin on it already. I don't actually know. And then we will, in another future stream, install klipper and go back to what we were, but with the nicer board. All right, so here's the screen. Let's do something simple like home all the axes. So this is the sound of the printer right now. I don't know how well it will pick up on the camera video. Pretty loud. So that's not too annoying when it's just doing a home movement. But when it's that sound constantly because it's printing something, it does start to... Oh, the end stop didn't trigger for some reason. I think it triggered the second time, but let's home Z again. Yeah, not sure what happened that first time. There was a... it didn't want to trigger on that first probe for some reason. Well, that'll all be different anyway. All right, so anyway, it may not seem like a big deal until you have had a printer that does have the silent stepper drivers and you are near the printer. Like if you put the printer off in some other room and just let it be, then it doesn't matter what it sounds like. There are going to be other advantages for this board as well. It is a more powerful board. It's a 32-bit board versus the one that's in there now is, I don't know if it's an 8-bit or a 16-bit board. But it will let us do other things, just the board itself, if we wanted to. That would be an upgrade over the older board. It's not terribly expensive, like we saw here, $44 for the board itself. And the nice thing about this one is that this is specific. Now, I guess it doesn't have to be in a Ender 3, but it is specifically designed to where it's a direct replacement. Like everything, all the little plugs are in the same spot. The whole bolt hole pattern is the same. And so it literally goes in the exact same spot that the one we're going to take out of. Not all of them are like that. You know, this board is much larger. It has way more drivers on it for doing some other things. It's got different location for where the power's coming in, the fans and the end stops and everything. So it's a totally different form factor. Here's another one that's a different form factor. Although actually that one might be the same form factor as the Ender 3. Now that I'm looking at it, it's just rotated. This one does show us something though that I can. Actually, this one is cheaper, isn't it? This is a version 2 E3. So it was the cheapest one I guess I could have gone with. I guess I just didn't see it for whatever reason. So this one is the actual cheapest silent board. Actually, is this one a silent board? I don't know that this one's silent. I can't see the actual drivers on it. They're under these blue heat sinks. That's where the drivers are. And I can't tell if they are silent or not just by looking at the top of them. I would suspect if they don't have silent in the title up there. Oh, there they are. They're 2209s. I think those are silent. I think the 2209s are silent drivers. So maybe that would have been $35 and I could upgrade and get the same effect. Since I'm not actually using the board itself for doing a whole lot of process or any processing, it's just collecting the data, sending out the signals, and I'm going to be using the Raspberry Pi as my actual G-code processor. So probably could have gone with this board and had the same effect, but I didn't see it. The other one looked cooler. Anyway, let's get into our printer. Actually, let's turn off our printer and get it all unplugged. I don't want to have any electrical issues with that. So let's get this back out of the way. And let's see if we can, well, let's see what's in our box. Alright, so this is, I haven't opened it at all apparently. I'm supposed to pull here. Okay, there we go. I was supposed to pull this way apparently, because that looks like the top. So we got a board, we get the Big Tree Tech is the company that does these, and they always put a little rubber duck in there. This one got a little flattened. There's the board. We do have a USB cable. We won't need that, I don't believe. So this little packaging is electrostatic, so you do want to not confer any electrical discharges to your board. The bottom side is pretty open. This big copper strip here is your heat sink combined with, it looks like they've got, yeah, that's aluminum, so they've got another heat sink on top of it. There's going to be a fan right here kind of blowing across these fins. But basically all we need to do is get our existing board out and plug in everything the exact same. I do have some jumpers here. There are some locations for jumpers if I want to install different things. Let me see real quick. It's kind of hard to read what some of these are. I might have, so we did get that that light kit. It might have a direct plug-in to one of these that will let it be controlled from the board versus just an on-off switch. I'll have to see. All right, so first we need to get to our printer. I'm going to have to rearrange it so that I can get to it, and maybe rearrange you guys so that you can see. It's not a terribly hard change to make. Let's get the bed back out of the way. I've already, for whatever reason back in the past, I've already taken the cover off of here. Let's get y'all farther over there and closer in there. Maybe some light. We may or may not have the light. So one thing with these boards is that, at least the Creality ones, and a lot of them are like this, is they do hot glue in the plugs so that they don't accidentally come loose, maybe because they are shipped from China. And so if one of these came unplugged and somebody buys it and they don't know what they're looking for, then it might be an annoyance, at least on the service department, to, well, have you tried plugging in the wire again? And there are some that maybe you plug in the wrong thing in the wrong spot. Anyway, that's usually a little bit of a pain because you have to get this glue out of here without tearing up any of the plugs. So sometimes it will just come out. Other times you have to X-Acto it out. So we're unplugged. We don't have any power in here. So we should be okay. Let's go ahead and get some of the stuff out of the way. This is our, we added this, but not in this. I don't think I added it in any stream. This is the cable for the CR Touch, the bed sensor. As part of this, we'll actually route this the right way instead of just kind of around the printer. Since this is unplugged because this was the Z end stop, which we aren't using because we're using the CR Touch. All right, let's see if we can get this fan so that the little cover can go out of the way. And I'm going to see if I can get some of this glue off of here without tearing up anything. There's nothing wrong with this board. So I don't want to tear up the board, but mainly I don't want to pull the wires out of the little socket here because that would be a pain to put back. I'm going to get some needle nose pliers. Right, I'm going to try and pull the glue off of here. There we go. All right, so that one did not come out the way I intended for it. There's still more glue on the other side. So the little socket here came off of the board, but that's not a huge deal. You can just drop it back on there. Do need to get it the right way though. Let's see, this is the right way. I may have to put it on once I get there it goes. So that little part it's not part of the electrical connection other than it clips the plug from the fan in. So if any of those do happen to come off, they're fine. You just slide them back on there. They're just plastic retainers. All right, so we got that one out. Now this can come out of the way. See, this is what they put on there. I would recommend removing that so that it's not in your way. It's very gummy hot glue, but it usually will peel off. I'm just peeling some of it off of this thing. The main thing is you don't want to accidentally pull the wires out of the socket here. You can fix that. They do just plug back in, but then you have to plug them back in the right way. And if you somehow pulled the little, see that little metal piece in there, if somehow you pulled that out, then you'd have to set the ends. let's see, what else can we get out of here? So these red thicker wires, those are the ones that are power related. I think I'm probably going to have to cut that zip tie. Maybe not, but I think it'll make things a lot easier if I do. So let's do that. Oops. So I don't want to cut these wires. There we go. So that'll give us a little bit more slack. These are all of our stepper motors. So you have 4 because you have an X, Y, and a Z axis. And the 4th one is your feeder motor. So for us, it's this motor right here. You know, that's the extruder motor. All right. So, and again, they've got glue on every one of them, big globs of it. I'll see if I can just pull the globs of glue. There's one. 2. If for some reason, I have not, all of the Creality printers do this, and I assume most of them do. I just haven't opened up every printer out there. But if they don't have these little labels, these little tags like E and Z and X and Y, then you probably will save yourself a lot of time if you put masking tape labels, or you put some kind of labels on the little wires so that you get them back in the right spot. Okay, so there's our extruder wires. This little guy back here, that's a fuse. You don't have to pull that out. If you ever plug your printer in and you hear a pop from this area and you lose power, at least check, you know, unplug stuff again, but at least check and see, maybe you just blew this fuse. Now, why you blew the fuse is a different thing, and you may not want to just plug a new fuse in without trying to trace down why you blew a fuse. But it could be that something caused that fuse to blow, and you can just replace it. But if you replace it without figuring out why it blew in the first place, then it might just blow again. Okay, let's see. These little green terminals, these are screw terminals, and we need a little screwdriver and loosen all of the little silver screws along the top, and these wires will just slide out. But I need a screwdriver for that, flathead screwdriver. Which is this one, or is this Phillips? Oh, here's one. So got this one. You don't have to take these screws out. You just have to loosen them. We'll look at how they work once we get the board out. Again, these wires are usually not labeled, so you do want to get these back in the right spot. Now, fortunately, they are different enough that you can tell which ones go where. So the biggest wires, that red one, and there's a black one that size also, those are the power coming in, so from your power supply. Those usually, you know, they're going to go into the block back here. Now our board that we're replacing it with, on the top side, I don't see any indicator which one is positive and negative. But on the bottom side, there's a ground, that's going to be your negative, and a DC, so direct current, so that's your voltage in, DC in. So the red one's going to go on the input, or the V positive, or whatever it might be. And the ground, the negative, the black wire is going to go on, in this case, the GND, so the ground one. And I think that's the same order they had them here. This first one is, oh, now I've only got 2 here. So what do they have a third one for? Let's see, I can't see what's going on down in there. I might have to double up. Let's see, they've got, it gets crowded down in here. I think this one's just a fan. What is this? Did I not get it loose enough? .24 volt, and I think that is probably going to this fan. Maybe not. What else would it go to? Because that might be this fan. Oh no, alright, so yeah, I got it. So the one that was just wired in, this is to a fan, and it's the fan right here, so I can't show. Oh, there's the one I just unplugged. It's to this fan. This fan is the one that's blowing on your hot end, on the cold side of it, the heatsink side, and it's always on. So they just wired it into their power here. This one, well, the one that was here that we pulled the little socket out, that was the fan on here. That was this fan. So the cover for cooling the board itself. This one is the fan on the side over here. That's the layer cooling fan. It is not always on. Sometimes it's on, sometimes it's off. So they do need to be in separate locations. But this one, I only have 2 of these terminal blocks. This is one the power comes in, and then I've got these 2. I'll just match it with one of these other inputs here. We'll see what else is got plugged in. We'll figure it out. We could put it into here, I suppose. Maybe that's what we'll do. This will be always on. I think we'll also put it in here, maybe. I don't really like putting it in with the main power in, but these 2 are, well, I think they're also just power. Let's see. So, well, one of them, we do have to have it matched up though, because one of them's the heater for the bed, and one of them is the heater for the extruder. So we don't want to mix those together because they're only on when the bed or the extruder's on. And this board doesn't. Oh wait, maybe. I think those both have the PC8 and PC9. I'll have to look at a pinout, which, let me see if the box gave me anything. No, I think it's all digital, so I have to, oh wait, it is. Alright, so the pinout is on the bottom of the box. So, and it's in a white silk screen. Wow, that's going to be hard to read. I'll have to zoom in on that to see what we've got there. Alright, so it says hotbed is the top one, or, well, it's backwards on the way you're looking at it, and the extruder's there. I might have to put the always on fan right here, or I would have to put a socket onto here so it can plug into the board somewhere. And I don't really want to do that right now. Alright, we're moving along. This little colorful cable is going to the screen. Is it glued? Oh, it's glued into. It's kind of hard to get to it. There's that. I think it had some on both sides. Yep. So that can go out of the way. We've just got our end stops now, and they've got glue gummed on everything. A little piece. That one had some green in it. Not sure where the green came from. Got some green, or yellow lime green color. Looks like there's some on here too. Maybe they sometimes use different colors of glue. All right, I think we're good with that. Again, same thing on the end stops. You want to make sure that they're labeled. Otherwise, you have to go trace down where this wire actually ends up, and it's kind of hard to do because they run through the frame, and so it can be difficult to figure out. I guess you could use a multimeter and a continuity check. Actually, these, oh no, Z, this one's not labeled. All right, Z we don't need because we're using the, that one's already unattached. I do have some unlabeled ones. That's interesting. I have XY. So what are these guys do? Oh, these are my thermistors. So one of these, and they're identical. This is not great. So one of these goes to the bed thermistor, and one of them goes to the hot end thermistor. And there's no label of which is which, and I don't know. I should have paid more attention to which one was where. It looks like this guy is the extruder, because it looks like it just going by the way the wires want to fall. Which I think it's the extruder. I think this is the extruder. Let me mark that. So the board itself has writing on it, and but the wire does not. At least this one does not. So I don't know which one that goes to. All right, so everything's. I think this is the extruder. The other one will be the bed. All right, now there are a couple of little screws down in here. Got to find the right size Allen though. It. Yeah, probably need a longer one than that, but this will work. Okay, that one. Not every one of the holes. Oh, before I forget, there's a SD card in this little slot right here. It's best to go ahead and take that out because it protrudes through the frame or the box here, the sheet metal. And you can snap those off if you're not careful when you go to take the board out. If you really want to, you can take this whole little tray out and work on it kind of detached from the printer. Might give you a little more room to work. Oh, there's one more. Like we're still, there we go. All right, so there is our board. I need to get all those screws out of it because I need to reuse those. It had 4. All right, so here's how those little screw terminals work. They have a little jaw in there that as you loosen or tighten, well, this is loosening, this is tightening, that little inside part moves up and down, and you want to loosen it all the way. Put the wire in the gap and then tighten it down, and it'll pinch the wire in its little jaws. If any of these are loose, this one's a little bit loose, that can create a problem. You want a really good connection on your power side. If you have a kind of good connection where it's connected but it's not secure, then what can happen is if it wiggles loose at all, then the resistance, since it's not as electrically connected, it's not crimped down really well, it's not a good connection, electrical resistance goes up. And if you remember Ohm's law, voltage equals current times resistance. Well, voltage isn't changing, you're just putting 24 volts in there. If you change the resistance, make it to where it's not connected very well, you'll change the current also, and you can change it in a way that will make things much worse. it will potentially burn. Let me, do I don't have that anymore. It will potentially get hot, and it could burn, could melt. So you want to make sure that you've got good connections on here and here. Also these, but these are at least going to be pretty obvious if they're connected or not, because they snap in place. So here's our two boards. Well, actually, let's arrange them the right way. There's our two boards. For the most part, everything just plugs from one spot to the other. Now, I do have lots of new spots. You know, I've got all of these now. So there's a TFT. So there's one. If I have a touch panel screen, I can just plug in. Usually there's some of these that are LED. It's hard to see what the writing says. There's a fan. So the fans are in slightly different spots, looks like. So these are where the fans were. This was the case fan, the one that's cooling this board itself. And this one was the layer cooling fan. And it looks like I'll have to track down which one of these is which fan over here. X, Y, Z, temperature for the, I think the hotbed. I looked at those backwards. I think the one that I marked is actually the temperature probe for the bed, the thermistor for the bed. And then we have the temperature for the hot end. So it'll be, again, clear once we plug it in and see what the temperatures say. These are underneath these are stepper drivers. That is the main reason we're replacing this. Underneath this big shield is the new stepper drivers. They look similar. These are not the driver. These are just heat sinks, and the drivers are underneath there. We still have a fuse. It looks like it went from a 15 amp fuse to a 20 amp fuse. So we have our SD card slot, our USB slot. So everything pretty much is going to be just plug it back in. We're going to have to adjust a few things. Mainly, it looks like I'm going to have to put my heat sink fan in here, which I don't want to do, but I don't have a better way. I'm supposed to plug it into this, I think, but I don't have a plug for that. So you could go about this a couple of different ways. You could screw the board down and then start plugging things in, but this is the most important connection. So I'm probably going to do this one first with without it being plugged into the, or screwed down to the holes, just so I can make sure that that one's pretty good and it gives me more room to operate. Now these are the wires that go in there, and there's not a lot of slack with those. There's a little bit. So I'm going to pull this whole wire bundle forwards a little just to be able to get to it, because those are the ones that I'm most interested in having nice. See if I can figure out the best way. I think they had it like, I don't know why they had it that way. Can it go this way? They're in the wire bundle a little oddly. And so the red one is going to be my power, and the ground, just to confirm. Whoops, I don't do that. A lot of times they're written on the top, but this one's written on the bottom. So ground is the one closest to the edge, so that is the ground. And power, where's that? These are, I guess I need to put these in that same spot. I don't like that, but I do need some way that they're always on, and I don't have any other terminal blocks to work with. These are power blocks, but they're only on when the heaters are on, the extruder and the bed. I don't remember which is which. Oh, I had to look at this, didn't I? Let's see. So, bed and extruder, hot end, E0. All right, let's see if we can make sure that these are open. So you can kind of see the little jaw opening up to where the wire can go in there. And let's try to get this to work. All right, so since this is a fan, it does matter positive and negative. So I want the two reds together and the two black wires together. And wow, it's tight down in there. Let's see if I can get that thing out of the way. Having the camera here is challenging. I wonder if I can get this to come any further forward. It is limited on how far it can go just because of how long or short it is, rather. Would be nice if I had a little more slack. I don't think I do. And then I want this guy to also join. It's be tricky. I may not, oh, you know, I really should, if I want these to join, I really should solder them together versus relying on this to clamp them together, because they may not. Yeah, that's going to be kind of hard to do. Let's let me think real quick. Let me look at our options here. Fan, that's fan 2. Trying to read this super tiny. Actually, it's easier to read on the screen because it's tiny. And I don't know why they chose like white on silver. That's not a lot of contrast for reading this thing. I don't know if I have a plug that I can quickly put on here. They're not super easy to put on, and I don't know if I have one available. And there's no other screw terminals, so that's just a bit of a pain. I could at least strip these back to give some more connection, because I don't know that this is going to stay very well. So what happens if this comes loose? What would happen is this fan would stop running. This fan is cooling the heatsink. If that is not actively cooled with this air blowing across it, then as you're printing, you'll print for about 15 minutes, 10 or 15 minutes, and the heat from your hot end, the actual heat block, will gradually work its way up into the cool side of your whole hot end on the heatsink side, and the part with the fins. And the filament inside there will get softer and softer until it won't necessarily get molten like it's ready to print, but it'll be so soft that as you try to feed more filament in, it can't push it anymore because it's just kind of gooey. And it will clog, and your prints will gradually lose the material. So it'll keep moving around, and it might even squeeze out a little bit of filament, but you'll have eventually, at about 15 minutes or so, you'll just be printing in air. And nothing will be coming out, and it's a clog in the cold side of your hot end. So we really don't want this fan not working when we're printing. So I think what I'll do is I'll try to strip some of this wire back so that I can get more of it around here. So I'll need a wire stripper for that. Alright, I'm going to use these. If you do a lot of wire stripping, these are pretty handy. They're kind of, you just put your wire in here. It grabs with this side. Now this particular set with the small wires, I usually have to push down right here. Oh, where are we at? There we are. And there. So you can, I mean, this is kind of wire you could strip with whatever, but these are pretty handy. All right. Now my plan, again, these wires are so short. My plan is I'm going to try and get this wrapped around here. A better plan would be, well, so the best plan would be to go ahead and find the plugs that will match here and fix those ends with those plugs so I can just plug it into the, well, that's the wrong board. Plug it into the slot right here. That's the best plan. I don't think I have any of those plugs right now to do that with. So better, but not best plan would be do what I'm doing, but solder this together. Or use the, none of these have them, but use a little ferrule that it's like a little barrel that you put over here and you crimp it in place. That would be a better plan. Don't think I have any of those right now. And then the next plan would be do what I'm doing but solder it. And then the worst plan, the one I'm actually going with, is wrap this around, crimp it down in the terminal block over here. I don't think this is going to be a long-term plan, but it's what we're going to have to do today just because I don't have the options for any of the other plans today. So I stripped the wire back a little bit and I've got it, you know, kind of wrapped around here to hopefully grab in the little crimp terminal block. I need to do the same thing with the ground wire, which is even shorter. Like there's hardly any of it coming out of the little wire bundle. Let's see if I can get it around there. If you were doing this like for your printer, I would either get the little barrels that you can crimp over these wires and it makes them one wire that you're going to crimp down in the terminal block. And if you had the option, it's just you have to have some other tools. I would do put the plug on the end of here. You can do it without other tools other than like pliers. It's just they're difficult to do. So I would not do it this way. Make sure those are open. Yes. See if we can, yeah, see, because that's going to be a ongoing problem trying to plug this thing in. So I said that these were, oh, they just plug them, they're just one-to-one plug-ins. And usually they are, but for some reason, this one is not. In fact, let's see. In fact, if I had gone with the cheaper one, look, it has the third terminal block where I could just plug in my fan just like I planned to. Not the, yeah, the fan. Versus having to route it over here if I'd have gone with the cheaper board. That'd have been better. I guess I should have looked closer. All right. I assume that why the version 3 board probably matches up better with the newer Ender 3 printers that have their wire for their fan is socketed or plugged, so it can plug into one of these versus going. They're probably like, nobody has those printers anymore. Why would we need to do that? Wow, this is, y'all probably can't see anything right now, but this is being a pain. the combination of trying to keep the wire here and get it all into the little jaws of the block is not something I want to have to do very often. Part of the problem is the different links in the main power wires are so different that the red one is putting pressure on the board to move it where I can't get the black one in there. I'm having to try and hold it all together at one time, and it's just not cooperating. Alright, so I actually think we have it functional. Alright, so now what we need is, let's go ahead and do these. Let's get you back kind of in the camera. Where are you going? Maybe like that. So again, we've got to consult our wiring diagram here. So the top one is the heat bed, and the bottom one is the extruder. And I've got the these look similar to the power wires, but they're not quite the same. Actually, they might be the same. And then these that are they have a waxy coating. There should be two of them. So the waxy ones are the extruder, well, no, let me make sure. Normally they are, but trying to see them. I think, yes, I think these are the extruder, and the plain looking ones are the hotbed. Now, the good thing here, at least, is the hotbed has a positive and negative, but it is just a resistive heater. But let's try and match it up. So it has the positive on the side this way. So negative here. Normally, for resistive heaters, though, it doesn't matter positive and negative. But maybe the bed has some diodes, because the bed heater is like a circuit board, and so maybe it has some kind of direction to it. Oh, you know what? I never opened these. Let's open these. Go ahead and open all of them. Oh wait, steppers are different ends on the SKR. Oh really? That is not fun. Oh wow, they're backwards. So we'll see what happens to us there. Let me check something. Let me check. So here it does say silent board for Ender 3. Not Ender 3 anything special, just Ender 3. But what he's saying in the chat is these plugs that are kind of on the right hand side here, with the 4 white dots, those are pins, that they are backwards from what we have on our original board, and they are turned backwards. That'll be, I don't know if they are going to be backwards and function the other way around, or if we're going to have to switch those pins out. That'll be not as fun of a job for these plugs. You can, if you have to, switch the pins. We'll see what happens. I don't know. They might go the wrong way. So this one is the hot end. It does not. They're both red, right? There's no positive, nothing that would tell you one of these is positive or negative. The hot end heater is just a resistor, so it won't matter which one we put in which side here. Oh, yeah, and I just did it. When you are using these terminals, it is entirely possible to put the wire in here, screw the thing down, and think you have gotten it tight, but nothing, and your screwdriver is tight, but you didn't actually crimp the wire. So when you do this, make sure that you actually give a little tug there to test, to make sure that you actually tighten the wire versus just tighten the screw down, because you might have slid the wire under the jaw and you tighten the jaw but without the wire in it. Also, it's best that you don't leave. Now look, I left a tiny sliver of metal showing there. It's best if there's none showing, but you certainly don't want lots of exposed metal from your wire there, because they could short out. All right, save that one. Let's go ahead and put at least a few of the screws in to get our board more stable. It's kind of floating around here. I don't know if we have to put them all in, but let's put some of them in. Let's see. I lost the... Let's put this middle one in. Is it going in there? I don't think it lined up. There we go. It's not cooperating. There we go. All right, so we got the one. You do have to line up the USB and the SD card with their slots. They lined up pretty well. So we'll just put that one in for now, and work on this and then get those. Let's go ahead and see about what's going to happen with our stepper motors. So, which ones are where? So the very top one, according to our wiring diagram, is X, Y, Z. There are two Z's and a extruder. So that's why I have an extra one here. These two in the middle here are both for the Z axis, in case you had a dual Z that where both of the steppers were separate. We do have that kit for the dual Z, but it would not cause them to be separate stepper motors. Can't find X, Y, Z. This one it? X. All right. So matching them up here is going to require us to put it twisted around. Now, what I don't know is it just going to twist the wire around, or are the steppers actually wired differently from what they were before? I think I'm going to have to undo this zip tie because I'm having to twist the wires 180 degrees from what they were, and so I just need a little more slack. So the next one will be Y. Let's route it under that one. Oh wow, that is super tight. Z, it doesn't matter which of the Z's we use as far as I remember. I'm going to use the first one. Usually they are doing the exact same thing, running off of one driver. And then the extruder, which got to really stretch. And then we might as well plug in our screen. Okay, and then we need our, let's go ahead and put our fan. So this fan is the layer cooling fan. Which one of these is the layer cooling fan? Let's see, on the old board it was labeled as fan 2. And on here, fan 2 is this first slot. Okay. Now the case fan was plugged into fan 1, and on here fan 1 is this one. So it's the one that's kind of in the middle. I don't know where I've put the case right now. Here it is, I think. Now I've got my end stops and my thermistors. So I don't have a Z end stop, so I have X, which is, according to our diagram, X is the third one. Usually the end stops aren't directional, I don't believe, because they're just switches. And then Y will be next to that. If we had Z, it would be next. And then the last two are the thermistor for the hotbed and the, oh wow, just that. It's hard to read. Let me see if I can see it on the screen, on the camera. Can't get the camera to focus on it. Alright, so the THB is the thermistor for the hotbed. TH0, that is the thermistor for extruder 0, which is the hot end. And on our old board, where did I put our old board? It was bed and, alright, so I think we'll see if our temperatures make sense. But I think this guy was the one that goes in the bed, and this guy's the one that goes in the extruder. Alright. If I can get it in there. That is hard to... Alright, so everything's plugged up. It could use some better routing, but before we do a bunch of routing, let's plug some stuff in. Let's make sure that nothing obvious is shorting. I don't see of anything that looks like it's shorting. Let's see if we can plug in and see what happens. So what we want to happen is, I don't know what kind of firmware might be running on this thing, if any. So we may not get anything on our screen. That's possible. See if I can get kind of back around where everything's visible. What we don't want is any, smoke. It's always a possibility. But we want this fan to come on. We would like our screen to at least be blue. Maybe it will boot up to something, I don't know. And if it does boot up to something, then we'd like to check our stepper motors. But I don't know if it'll boot to anything. Alright. Alright, it did boot. It booted to Marlin Bug Fix 2.0. Our screen looks reasonable. We do have this fan on. Our power light is... No, we have something flashing on the board there. That does not make me super happy. But I don't know what... We've got one light that's on and one light that is flashing. Let's do a quick Google search and see if that light is what that means. Let's see. It's a firmware issues usually. Which or firmware at least seems to be on. It, in some cases, it could be. Oh, it could be a connection with the BO Touch being a problem. Oh yeah, I didn't plug the BO Touch in. All right, so let's shut it down. We've got this guy, and where is he gonna go? Again, I really wish. It's hard to see. I think it's saying that one, which of course is right in the way of the wires for that one, for the screen. Maybe it's that one. That says Z probe, and this is the Z probe. I just can't tell which way it needs to go. I think it needs to go this way. There are some little slots that look like they have to line up this way. Well, I may have to plug this one in first and then that one. Alright, power back up. Oh, it did. And there's no more flashing red light. Oh, it is flashing. Alright, well, that wasn't plugged in. Alright, let's see if we have... let's check the motion, since we had to flip our stepper drivers. I don't know if it'll let me move an axis without homing, but let's see. Oh, it did. X is the right way. It just won't go very far because it thinks that's 0. So X is correct. Let's see about Y. Also, moving, and all you can hear is the fan. So X is good. Let's check Z. It may not do Z because sometimes it won't let you do Z. I'm going to go in 1mm increments here. Huh? Alright, so all the directions are fine for that. So let's do a home all and see if our... Actually, let's home one at a time. So, do I not have a... what if I do move axis? Can I home... Oh, do I have to home everything at once? I'd really rather just do one at a time. Alright, so... zoom you out a little bit. So is it going to trigger? I've got ready to shut it down. Nope. X trigger works fine. Y trigger works fine. Did not home in Z though. Interesting. Oh, alright, so it probably didn't, maybe a couple of reasons it didn't home in Z. I don't know that this firmware, this is the firmware that was on the board, right? So it's just whatever came in the box. It may not have a bed sensor in that firmware, and I don't have the Z plugged in. So it might be that until I change the firmware, that it knows it even has a bed sensor, and I don't think I'm going to be able to do that from here. Oh, now I am noticing the layer fan is on and this one is not, so I kind of think we have these backwards. So let me test this. That's main fan speed. All right, so in the menu over here, I'm going to do fan speed to, I don't know, 100%, and see if this fan comes on. No, but that one is. So let's turn fan speed to 0, which it was already. Alright, so our fans here, this fan could be right. Sometimes this fan is controlled by a temperature, and it comes on, you know, when it needs to. But this one, well, keep having to go back and forth. This one is a layer cooling fan that should be controllable. So this fan is not plugged in where it needs to be. All right. So what that means is we've got some more deciphering to do. We have to find that fan, which is here, and find the spot that it needs to go into. It was in fan 2, which I put it in fan 2, but maybe fan 2 on this board is not the layer cooling fan. So there's a little bit more. I don't see a better place to put it, unless it's this. That, I think, is the fan on. I think that's the fan spot we were supposed to plug that other thing into. I do have this fan Z. Maybe it's fan 0 to match up with the extruder, being E0. Let's see. All right. Okay. So this fan's still all right. This fan's still on. This one's not on now. Let's see if I can turn it on with the menu. Yes. All right. So it's supposed to be in fan 0 to match up with this being extruder 0. The only one that I'm kind of worried about now is this guy. Is it going to come on later, or I could just plug it into the fan 2 spot that was just always on and have that always running. That's probably what I'll do. So the other thing we have is the heat bed thermistor. You know, which one of these do I have the thermistors in the right spot? So we're pretty much out of time. I think we'll leave that for our next time. So what's remaining is we got to make sure our fans are right. Oh, not our fans, our thermistors are right. Need to clean this up, button it up. We need to get our, well, I guess we don't need to get our firmware on here. That would be if you weren't going to do Klipper, you would put your firmware that you do want on here. I don't think this one has BO Touch or CR Touch in this firmware, so it's not doing any homing in the Z direction. We're going to go skip that and go straight to installing Klipper. And so next time on Wednesday, I'll probably just troubleshoot the rest of this and let you know which way to, if we had the thermistors right or not. And then we'll jump right into putting Klipper on there. The other thing is I really don't like the way I've got this fan wired in. It's not ideal. So I'll probably order some connectors, or see if I can find some that will let me plug it into the board instead of kind of rigging it together back there with the power supply. All right, we'll turn this off. We do have the new board working. It's not this particular one is not a direct drop in, even though it says it would be, and I've done it before and not had quite so much trouble, but we would have had less trouble actually if we'd have gone with the cheaper board, because it has a terminal block for the fan instead of a plug like one of these. And we'll come back and see what we have working for next time, and hopefully get Klipper installed on this thing and go from there. All right, I will see y'all on Wednesday.